Good morning and welcome to the first of 6 webinars in the Utah Connected webinar series hosted by the Utah Department of Transportation. My name is Muriel Sochmil and I will be your facilitator for this event. All webinars are free and open to the public, but advanced registration is required. I would note that this meeting is being recorded and recordings will be made available to the public within 1 week after each of these 6 webinars. This webinar series is intended to foster collaboration and promote information sharing among UDOT and its partners. The webinar series will highlight 6 successful deployments across Utah, including significant deployments with connected vehicles that have helped to improve mobility, safety, and quality of life for Utahns. The webinar series is funded through the United States Department of Transportation's Advanced Transportation and Congestion Management Technologies Deployment Program, or ATC-MTD. ATC-MTD provided competitive grants for the development of model deployment sites for large-scale installation and operation of advanced transportation technologies. UDOT was awarded $3 million from the ATC-MTD grant program. Along with a $3 million state match, the total $6 million funded program makes up the Utah Connected program. So this first webinar will really provide a high-level overview of that program. Before we get into our presentations from our select group of presenters today, we wanted to ask our participants a few questions. What role best describes you? We'll take a minute and please feel free to answer these questions. The second, what industry sector do you work in? And the third, how long have you worked in the field? We'll give it another 10 to 15 seconds for everyone who's just hopping on to respond. Okay, we'll end the poll and share the results. It looks like we have a majority of attendees this morning that are engineers, a good number that are consultants, researchers, planners, and policymakers. And it sounds like we have a diverse kind of group here this morning with some folks responding other. Would love to know what that is. Industry sectors, a good sampling of folks from both the public and private sector, as well as academia and nonprofits, and folks that span the course of their career, with some that are starting out within the profession, as well as well-tenured folks who've been with us for decades. So thank you for taking that poll. Now let's dive right into why we're here today. A little bit about the Utah Connected program. It was established as a statewide transportation system, or the program has established the statewide transportation system equipped with real-time situational awareness. Built on an extensive fiber-optic network, the system includes a robust data ecosystem, transit signal prioritization, automated weather and speed warnings for drivers, and the like. So we have a good lineup of speakers today, and we'll get right into our first one. Ivan Marrero. Ivan Marrero has served as the division administrator for the Utah Division of the Federal Highway Administration. In this capacity, Ivan oversees the division's day-to-day operations and its mission to administer and deliver Utah's $350 million federal aid highway program. Ivan joined FHWA in 1991 and has served assignments in Oregon, Maryland, and Oklahoma. He earned a Master of Science degree in Geotechnical Engineering from Oregon State University and a Bachelor of Science degree in Civil Engineering from Florida State University. And with that, Ivan, we'll have you take it away.
Okay. Well, thank you very much, Muriel, for that introduction, and good morning, everybody. I am Ivan Marrero, and I am the division administrator here in Utah for the Federal Highway Administration. I've been here for 9 years now, and I have the privilege of working with this amazing partner in the Utah Department of Transportation. They are you will learn from the presentations in this series how innovative of an agency they are. So, and in our federal highways, we take every opportunity we can to showcase innovation, and we regularly tap into UDOT and then have them help us spread the word and the good things they're doing and show the value of the things they're doing to other state DOTs and transportation partners. So that's what this series is about. I want to welcome all of you to this series. And good morning. I forgot to say good morning, good afternoon to those of you on the east side of the country. Let me see. I want to thank you all also for participating in this series. I know you're all very busy, but I know that this will be time very well spent getting to know about the technology and also collaborating and sharing information. I think in the end you will be very, very satisfied, and that time will be very well spent. At Federal Highways, we recognize the impact that connected and automated vehicle technology can have on safety, mobility, and the quality of life. And like I mentioned before, we are very proud to be able to partner with innovative agencies like the Utah Department of Transportation to promote the technology. This series was funded with US DOT Advanced Transportation and Congestion Management Technologies Deployment Program funds, or ATC MTD. This was a program that was established in 2016 by the FAST Act. And basically, like Muriel mentioned, it provided competitive grants for the development and deployment of sites for the installation and operation of advanced transportation technologies. Every year between 2016 and 2020, $60 million were made available to agencies to apply for. And during that time, the program granted 58 million, granted funds to 58 projects nationwide. As Muriel mentioned, UDOT was one of the early recipients of one of these grants. The Utah Connected project was awarded $3 million back in 2019. But even before then, Utah was using this technology in several parts of the state. They were actually one of the they were first to build a connected vehicle corridor in the nation. They built one in Salt Lake City, in Salt Lake County, and then another one in Utah County. And and they also, I know they've also, early on, they experimented or studied using truck platooning, using the technology to allow trucks to platoon, or kind of, if you ever watch the video, these trucks are just driving very close together. So we studied that here in Utah. As far as those early projects, and I'm sure you learn more about this as you hear from the speakers in the series. But early on, we equipped buses with equipment where they could communicate with the traffic signals. And so if a bus was running late, they could adjust the signals to give them a longer green light, and therefore the buses could stay on schedule. They then expanded that to include snow plows. So basically, snow plows could then continue plowing nonstop throughout that corridor, and they would operate so much more efficiently. So again, two great uses of that technology. And they've continued to expand the use of that technology to many other areas of the state and many other different uses. And so you will learn about that as you participate in this series. You'll also get to learn some of the you'll get to learn that to get to where some of these leading states are, it's not going to be easy. The technology is complicated. Building the communication network is a serious investment, and the politics can also be difficult to negotiate. So, as my suggestion is, as you sit through these sessions, ask questions like that. Try to find out how UDOT was able to get where they are today. What did it take, not only from a funding standpoint, but also the politics and everything involved with this technology. So yeah, again, my hope is that as you sit through these sessions, you learn what it takes to overcome some of these obstacles. In the end, we're looking for, well, in the end, we know that these connected and automated vehicle technology will make our roads safer. They're going to reduce congestion. They're going to help the environment by lowering the emissions. So I think taking on this challenge, it will be well worth your effort. I want to conclude by thanking UDOT for hosting this series and the amazing X Factor team for organizing it. We would not be able to make this happen without all their amazing help. And I want to especially thank all of you for that time, taking time out of your busy schedule to participate. I hope you're able to, and I hope you're able to make it to all the sessions. And most important, I hope you can all come together at the end and continue to grow the deployment of this critical technologies. And with that, I want to thank you all again for attending, and I can turn it over to Muriel. Thank you.
Thank you, Ivan, for those remarks. We truly appreciate the partnership with FHWA and look forward to future opportunities to work together. We'll now move to Lisa Zundel. And let me introduce Lisa. Lisa Zundel has worked at UDOT for 20 years as the Traffic Management Division Director. While at UDOT, she has worked in project management, traffic and safety, design, and construction. Lisa has a Bachelor of Science in Civil Engineering and a Master of Engineering in Civil and Environmental Engineering, both from Utah State University. We look forward to hearing from Lisa today. Lisa.
Thanks, Muriel. I want to welcome everybody to the webinar today. Appreciate your participation in this to learn about some of the things that Utah has been doing to advance connected vehicles and connected technology in our state. I want to start off by talking about UDOT's mission, enhancing quality of life through transportation. For us, that means enhancing the way people move and moving people through our system in a way that works best for them. In this day and age, enhancing quality of life also means technology. It means giving people the things that they need in real time or the things they're looking for in real time and giving accurate feedback with that real-time information. Over the years, UDOT's done a lot of things from an innovation standpoint. From the first design build mega project that was done in the state of Utah back in the late 90s to accelerated bridge construction, moving, sliding, and launching structures on a regular basis here in the state of Utah. Ivan mentioned our extensive fiber network and connecting UDOT's infrastructure. We're at a 95–96% connection of signals and ITS infrastructure in the state of Utah through our closed fiber network. Additionally, we have several innovative intersections. One of the first SPUIs to be used in the state of Utah has been here for many years, as well as diverging diamond intersections and continuous flow intersections. Our central signal system in TSPM, excuse me, is a pioneering effort throughout the country. We've put a lot of effort into developing and sharing TSPM software, as well as our central signal system is shared with the municipalities across the state. So all of the signals within the state of Utah are not only connected through our fiber system, but are shared through that central signal system for operations so that we can work together when incidents happen to adjust signal timing and have all of our signals work together on a daily basis. And finally, the connected vehicles. Ivan mentioned the first operation of connected vehicle corridor in the US back in 2017 was here in the Salt Lake Valley. We started our connected vehicle program back in 2014. And one of its main focuses is to help us achieve our safety goals. Enhancing the quality of life for people using our system means safety for everyone. And so innovation has been a huge part of UDOT's DNA throughout the years. But one of the things we've learned as we've gone through these innovative measures is it can't be done without partnership and collaboration. Bringing people together in webinars like this and reaching out to our partners for things that are emerging technologies like connected vehicles, reaching out to our partners across the country, both private and public entities coming together to learn from each other and work together, and then developing partnerships with each other so that as we grow and learn, we're doing it in a way that benefits everybody and all the systems across the country. One of our key partners in these efforts has been FHWA and their support over the years for UDOT to try new things. As Ivan mentioned, they look to UDOT to be those innovators, and they've been very supportive of that over the years. And with the connected vehicle program, the grants and peer exchanges that they've provided for us have been a key to our success in this area. When you're bringing all that together, you think about what does this future look like? We have all of these things, the transit signal priority, the snowplow preemption that was talked about, work zone data exchanges and connected vehicles, understanding what a work zone looks like based on the information being sent out. But there's also all of those unknowns. There's all of the things that we're here to learn together that we're using to grow and develop our system, and all of that technology that's going to come together to make our systems safer, to make our systems work together, and really in the end to serve all the people that use our system to enhance their quality of life when they're out in the transportation system. So with that, Muriel, I'll send it back to you. I appreciate the opportunity to be a part of this webinar, and just hope everybody's able to get some things out of this webinar and make some connections where they can learn and collaborate with each other.
Great, thank you, Lisa. This is not an easy task, and UDOT does it so well. Now we'll transition to Blaine Leonard, who is really responsible for a lot of the successes we'll be sharing over the course of our webinar series. So a lot of you know Blaine, a man who needs no introduction, but we will give him one anyway. Blaine Leonard is the Transportation Technology Manager at UDOT. In this role, he leads the deployment of connected automated vehicles. He has chaired the American Association of State Highway and Transportation Officials Connected and Automated Vehicle Working Group, and is currently co-chair of that AASHTO Technology Subcommittee. He's also in the past led the SPAT Challenge Tactical Working Group. Prior to joining UDOT in 2001, Blaine spent 20 years in the consulting engineering business. Blaine has a bachelor's and a master of science in civil engineering from the University of Utah. We'll turn it over to you, Blaine.
Great. Thank you, Muriel. I appreciate that. Let me share my screen here. So I appreciate that introduction. Appreciate everybody joining us today. I want to thank Ivan from our Utah Division of Federal Highway Administration for those great introductory comments, for the confidence he has in us and our work. In general, I want to thank FHWA for trusting us with this grant funding. and for their grants team in DC who worked with us and helped move this forward, and the local Federal Highways Office under Ivan's leadership that has been with us through all the steps of this project and provide us guidance and help us with paperwork and other kinds of things we needed to do. And in fact, as has been said, these webinars are brought to you through this ATC MTD funding. I want to thank Lisa for her introduction of UDOT and some of the background we have here in innovation. UDOT is truly a great place to work, and it's leaders like Lisa that help make that happen. I want to thank Muriel Sochimel and her X Factor team. They're the ones responsible for organizing and coordinating these webinars, for pestering all of you with advertisements and reminders so that you can be here. And I want to thank all of our presenters from UDOT, from our partners at Utah Transportation, Utah Transit Authority, and all of our consultants, and I've listed them here. We could not have accomplished these projects without a large team of very competent consultants. And over these 6 webinars, you'll hear from each one of them. I also want to thank all of you who have joined us today. There are over 200 of you today, and will join us on future webinars, and those who will review these recorded webinars later. You're the reason we're doing this. We want to share with you what we've done, hope to be able to inspire some of you to move on and do some things like this. I'll tell you that everything we've done and everything we've accomplished has been built on sharing by other agencies around the country. And so we appreciate you joining us and being with us, and hope this is helpful. As has been mentioned, the goals of these webinars are to promote information sharing, to help to provide some insights and lessons learned on what we've learned through these deployments over the years, to foster collaboration with you, and to support and encourage all of you in your efforts. We want dialogue. We want to be able to share. We want to be able to help you move forward, and that's really why we're hosting these webinars, to share and make sure that you don't have to repeat the mistakes we've made over time. Our UDOT Transportation Technology Group was formed in 2016. These efforts were embedded in the Intelligent Transportation Systems Group, our ITS group, and in 2016, we pulled out and formed a separate group. We're within the Traffic Management Division that Lisa leads. This allows us to have close coordination with our folks in Signal Ops and ITS, Freeway Ops, Maintenance, and the other groups that are so essential to what we do here. We and our group are focused mostly on transportation operations technologies, connected vehicles, automated vehicles, sensor technology like LiDAR and distributed acoustic sensing, and related sort of topics. Our group consists of 4 people, so we're fairly small. We have a lot of consultant support that has enabled us to get done what we do. The goals of our transportation technology group are really focused primarily on safety, reducing crashes, saving lives, fitting within UDOT's strategic goal of 0 crashes, 0 injuries, 0 fatalities. Through these technologies, we hope to provide information to the driver, to the vehicle, to the control room operator, provide information that the vehicle can't see on their own, and be able to enable better decisions by the driver in the vehicle. We also have a focus on vulnerable road users. As it was mentioned by Lisa, we're not just focused on vehicles, we're focused on all the travelers. We're also interested in mobility, improving transportation options and reliability for all of our users, which fits within UDOT's strategic goal to optimize mobility. Based on these safety and mobility goals, we want to achieve full situational awareness. We want to know what's going on our roads all over the state. And that relies on these technologies and sensors, our fiber network, and other things. We also want to prepare for production vehicles coming off the assembly line, if you will, with connected vehicle equipment on them. We know that the safety goals we have are a bit longer term, and they require that the automotive manufacturers install compatible systems. So we want to be at the forefront of that development, demonstrate to the OEMs that we're ready for them, be ready for them, and encourage them to move forward. We have some projects where we're working closely with them to make sure that we're all speaking the same language and ready for each other. So Ivan talked a little bit about the ATC MTD program, the Advanced Transportation and Congestion Management Technologies Deployment. That's sort of a mouthful. It was established by the FAST Act in 2015, and it funds development and deployment of advanced transportation technologies to improve safety, efficiency, system performance, and return on investment for infrastructure. And part of the program is built to be able to demonstrate what can be done and then share that with others, which is what we're doing. As Ivan mentioned, over the 6 years of the program, with almost 300 applications for funding, 58 projects were funded, totaling, I don't know, $350 million or something on that order. So it's a very successful program over the years, and we are delighted to be part of it. We responded to a fiscal year 18 notice of funding opportunity. Were announced that we were awarded a grant in April of 2019 and completed our paperwork and agreements to formalize that in September of 2019. We were granted $3 million of federal with a requirement of $3 million of state match. Over the years, as requirements changed, the marketplace changed, our scope was tweaked a little here and there based on some of those changes. We added some additional state funds to make the system whole and be able to accomplish what we wanted to accomplish. So about $3.1 million of state funding. This grant and the funding in this grant has really been an essential component of our development and expansion of innovative technologies, including connected vehicle work. In this grant, which we call Utah Connected, we had 3 primary focus areas: connected systems, which gets us towards real-time full situational awareness. That's our data ecosystem and our fiber sensing project. Connected vehicles, where we built applications in the connected vehicle environment to be able to advance that technology. And connected people, where we did some work with an automated vehicle shuttle deployment here in Utah. Webinar number 2, we'll talk about the data ecosystem, kind of the broad-based, cloud-based system where we gather data, process data, create messages, share that data back out, and in fact can share that data with you as an interested researcher, for instance, for some of the work that you might want to do to advance this technology. Webinar 3 will focus on the deployment of this hardware and these technologies and talk specifically about our curve speed warning and spot weather impact warning applications. Webinar 4 will focus on transit signal priority and snowplow preemption, some of the unique things about deploying for those cases and how we've made those work. Webinar 5 will come around and focus on distributed acoustic sensing, which uses fiber to sense what's going along a roadway. The Automated Vehicle Shuttle Lessons Learned project concluded a couple of years ago, and we did a lot of outreach about that. And so we've chosen not to include this in this series, but instead have included a recent study that was actually not funded through the ATC MTD program on the readiness of our roadways for automated vehicles. And so webinar 6 is focused on that. So we've got a quick poll question for you as attendees today to get some sense as we move forward with these webinars about your experience with the deployment of connected vehicle systems, V2X systems in the 5.9 band. So Marrero will pop up a poll question here, and if you would each respond to that and give us some insights into your background, that'd be really helpful. I'll pause for 10 more seconds for you to be able to click on a response there. Mariel, do we have some results? Good, a broad mix of experience, some who've done a lot, some who've done a little, and that's great. I appreciate that. The follow-up question then focuses on what you and your organization, your agency, plan to do with respect to V2X technology in the 5.9 gigahertz spectrum. Some of you have quite a bit of experience with this, and some of you have less. And so I'd be interested to see what you're looking at as you move forward with this particular technology. Okay, thank you. Again, a good mix of folks who are looking to expand, waiting for some other developments, and plan to do something outside of 5.9 or don't plan to deploy it at all. So thank you for providing that insight. That is very helpful for us as we move forward. So I want to start by giving you kind of the big picture of our connected vehicle data ecosystem, starting at a very high level about intelligent highways and full situational awareness. We have recently developed a little video about our system, and I want to share that with you.
If you ask the average Utahn about the Utah Department of Transportation, they'd probably say we build and maintain roads. And although that's true, it's not the whole story. What many don't realize is that we're also a national leader in providing innovative transportation technology solutions to create intelligent highways, which help enhance safety and make our roadways more efficient. In fact, UDOT is already making significant strides by establishing an intelligent transportation system throughout the state.
The Intelligent Transportation System is a network that gathers data from a variety of sources and devices around the state to provide us with something we call full situational awareness. Full situational awareness allows us to know what's happening on Utah roadways in real time, so we can be very proactive and respond quickly.
The foundation of this system is UDOT's 3,200-mile fiber-optic network, 1,300 traffic signals, and hundreds of other signs, cameras, and other devices. And now, the latest element in our intelligent transportation system is connected vehicle communications.
At UDOT's Transportation Technology Group, we're installing connected vehicle, or CV, devices throughout the state, which will help us make.
Well, sorry about that. I terminated the video early. Let me see if I can fix that problem.
With specialized software that allow us to communicate and share warnings and useful information directly with travelers. They also provide us with anonymous information about roadway conditions, which can give us really useful insights about our transportation system and give us full situational awareness.
An early example of this connected vehicle technology is the Utah Smart Transit Signal Priority System. As part of the initiative, UDOT has been enabling select traffic signals to communicate with connected vehicles, such as UTA buses, UDOT snowplows, and emergency response vehicles. As a result, these connected vehicles can receive priority at enabled intersections and extend the green light time they need to keep moving efficiently. For example, if a UTA bus is behind schedule, it can be granted additional green light time from an equipped traffic signal and get back on schedule. Or a UDOT snowplow can be given green lights at intersections where it's actively clearing snow. Similarly, the traffic signals can receive requests for green lights from emergency vehicles, helping them to respond faster and save lives. The connected vehicle system can also send warning messages about slick roads or sharp curves to vehicles, helping them avoid a crash. These are just a few of the exciting initiatives that UDOT's Transportation Technology Group has been working on.
Ultimately, we're working to make it so that most vehicles on our road can share data with our connected vehicle system and with each other. That will allow drivers to know about situations they can't see, and it will enable us to respond quicker to incidents and congestion. It will also enable traffic to flow more smoothly and prevent more crashes. Remember, this is all about safety. It's a huge step forward for our state. Once we've rolled out the connected vehicle system, we're going to see a big improvement in the state's transportation infrastructure. It will make our roads a whole lot safer and more efficient. It's going to improve the quality of life for everyone who travels on our roads.
Sorry for that little video glitch along the way here. So I've snapped a little map of the urbanized area in northern Utah, Salt Lake County, Utah County, and some areas to the east, to give you a little background in the deployments of connected vehicle technology that we've endeavored to make in the last 8 years. We started, as has been mentioned, in about 2014 with this technology, and originally partnered with our transit agency, the Utah Transit Authority, and in 2017 opened a corridor in the Salt Lake Valley using DSRC, RSUs, and OBUs to support transit signal priority for buses that are behind schedule. Once we found that that was effective and working, we expanded it to 2 other corridors, one in Salt Lake County and one in Utah County, actually 3 other corridors, and added snowplow preemption for vehicles that were actually plowing snow. We moved on in 2019 and installed some RSUs along Interstate 80 as it goes from Salt Lake City up the canyon towards Park City. And at that point, we recognized that the marketplace had introduced a competitor to DSRC known as C-V2X or LTE V2X. And to hedge our bets, we started deploying dual mode RSUs that broadcast both DSRC and C-V2X messages. We also started to connect vehicles and gather insights from vehicles through the basic safety message to know where the vehicle was, how fast they were moving, whether their flasher lights were on, airbags had been deployed, those sorts of things. In 2020, we started to use the funding from this ATCMTD Utah Connected grant, and we added a few more RSUs in several places around the valley, including up Big Cottonwood Canyon, which runs up to one of our ski resorts, in the Park City area, at some signalized intersections, and at some freeway-to-freeway interchanges in the downtown Salt Lake area. These deployments were specifically placed to enable us to build our curve speed and spot weather impact warning messages for our vehicles. We also, at that point, started to build the data ecosystem cloud-based platform, which is known as Cirrus, and you'll learn more about that in subsequent webinars. And we started to place security credentials on the broadcast messages so we could secure them over the air. As you may know, DSRC operated in a 75 megahertz wide piece of the spectrum, and known as the 5.9 gigahertz spectrum, a small piece of the overall spectrum in the country. And in May of 2021, the FCC modified our access to that spectrum. They took the lower 45 megahertz of the spectrum and gave it to be used by Wi-Fi and unlicensed use, and left us with the top 30 megahertz. They then formally allowed this new technology, LTE V2X, into the spectrum, pending some final rules of operation. Prior to that, in order to deploy C-V2X, which we had done, you needed an experimental license with the FCC. So they formally allowed it into the spectrum. They also required that all DSRC operations be moved into this upper 30 megahertz, and that had to be accomplished by July of last year. They also indicated a long-term plan to phase out DSRC entirely by about mid-2024, although that date has not yet been codified by the FCC, so it may change. So that change introduced some unknowns for a lot of people. I would argue that, in fact, even though we weren't really excited about those changes and opposed them when they first came out, we now have some regulatory certainty. We know we have 30 megahertz to work with, not anymore. And we know that C-V2X or LTE V2X is the technology that will be used in that spectrum. So we've got certainty about those two things. Now, let me sort of parenthetically state that we talk about C-V2X or LTE V2X. People often confuse that with 5G, and they are not the same thing. 5G is a cellular communications mechanism that we use on our cell phones. It's the successor to 4G. It requires that communications go through a communications tower with antennas on it. C-V2X, LTE V2X, two words for the same thing, are just like DSRC. They communicate directly with other devices without going through a tower. They don't require a monthly charge or a fee. They're direct ad hoc communications, or side link communications, they're sometimes called. They use the 5.9 gigahertz spectrum. They're also not telematics. Most new cars today come with connected vehicle technology. That is really a cell communication using 4G or 5G cell networks to provide information into the vehicle. Those telematic systems communicate not with other vehicles, but directly with the manufacturer of that particular make and model of car. So it's very different than the technology we're talking about. We still need final operating rules to follow up on this first report and order that the FCC granted. We expect this second report and order maybe early to mid next year. It will refine the broadcast limits, the permitting process to actually install C-V2X devices, and will give us a final sunset date for DSRC. In the interim, before the second report and order comes out, we need to have waivers to allow each one of us to deploy C-V2X in the near term. This waiver process replaces the experimental licenses that some of us were using. The FCC issued the first joint waiver in April of 2023, just a few months ago, to 14 specific parties who had applied for the waiver. It includes the Utah DOT and the Virginia DOT, a variety of automakers and vendors of this equipment. Other agencies have requested waivers, and those are still pending. We're anxious for those. Those are really needed, and a lot of organizations are pressing the FCC to give those waivers so that all of you can continue to deploy like we are. So building on the deployments we did in 2019 and 2020, we continued to deploy in 2022 with what we call an enclave project. We partnered with the city of Orem, a mid-sized city in Utah County, and blanketed the city with roadside units. We essentially put RSUs, and everything we're doing now is dual mode RSUs. We put RSUs at every one of their signalized intersections and equipped a bunch of their fleet vehicles. This got us down the path of starting to provide emergency vehicle preemption and expanded our ability to get insights from vehicles moving around a fairly confined area. Our previous deployments were all linear because they were mostly supporting transit signal priority. And this was our first one in a concentrated area to really get a handle on the movement of vehicles in a fairly refined area, if you will. That was using some state funds. We then continued using ATC-MTD funds from our Utah Connected program to build several additional corridors in Utah County to expand TSP and preemption for both plows and emergency vehicles. And you can see those labeled here. So that brings our total deployments to about 340 RSUs in several counties and almost 300 vehicles equipped with OBUs. These systems broadcast a series of standardized messages, little data sets. If you're familiar with the Society of Automotive Engineers, SAE J2735 standard, we followed those standards and we broadcast a series of messages. Some of those are broadcast from RSUs at signalized intersections. Some of them are generated by the vehicle and broadcast by the OBU in the vehicle. Others are broadcast from roadside locations, whether they are signalized or not, like our Interstate 80 deployment. SPAT defines what the signal is doing, what the traffic lights are doing at an intersection at any given point in time. And the map message defines the intersection geometry. These two messages support a lot of intersection-related applications, including our TSP applications. To accomplish TSP, we need a request that comes from the vehicle requesting preemption, known as a signal request message, and the signal responds with a signal status message to confirm that the message was received. And so we're using those messages. Our vehicle insights come from a basic safety message. The vehicle populates the BSM and tells us a lot about what the vehicle is doing. We don't have the BSM fully populated with all of the possible data elements in it, but we're getting information about vehicle location and travel speed and some weather information, whether the airbag has been deployed, hard braking, those kinds of things. Finally, not quite finally, the TIM message, the traveler information message, is a very broad message that is used to send information to the vehicle about some kind of traveler information. We're using it specifically to tell the vehicle about a curve that they're coming up upon and what a recommended speed would be, or spot weather warnings about ice on the road or high winds. Finally, we've started to work with a message called RTCM. This is a message that is sent to the vehicle, giving it some correction information that the vehicle can then use to determine a better location, a more accurate location of where the vehicle is. It corrects the GPS message, if you will, for some variations that happen with the standardized GPS messages. With all those deployments, one of the things we've found fits in with a statement from the baseball philosopher Yogi Berra. In theory, there's no difference between theory and practice. In practice, there is. So in our practice of deploying connected vehicle technology over 8 or 9 years, we've learned a lot of things. And so I want to share some of these lessons learned, mostly at a fairly high level, because our other webinars will get into some more detail. The first one is that a significant amount of progress has been made in the last 3 or 4 years, an unbelievable amount of progress. We have that first report in order that I've talked about, which resolves the spectrum and radio systems questions. Several organizations have really dug in and created a lot of standards and guidance for how to deploy primarily at intersections. The Connected Transportation Interoperability Group, funded by the US DOT and operated by ITE and SAE, has issued a guidance document which is currently being revised as we speak, and some other related documents. The Crash Avoidance Metrics Partnership, which is a partnership of automakers, has done a lot of work in this area and provided some documents. And the Connected Vehicle Pooled Fund Study, which is an organization that pools the resources of about 22 or 23 state and local agencies in the connected vehicle world, has produced some really good documents that help us all to deploy. And so I'm happy to share links for any of these if you're not familiar with them, but there's some really good information out there. Similarly, a lot of progress has been made in the past few years on the hardware itself. When we started deploying hardware in 2015 and 16, the hardware was not mature, it was not interoperable, it didn't always meet the specs, and there were significant problems involved. Those have largely been worked through over the last few years. We have a new roadside unit standard produced by that CTI group. We have updated standards for our signal equipment and cabinets to support this equipment. And we now have certification processes for C-V2X devices offered by OmniAir and others. As I mentioned, the initial waivers have been granted, which establish some power limits and really sort of set the stage for what our operating limits are going to be. Security certificates to secure these messages are available from a US-based vendor and from several other non-US based vendors, frankly, and we have new standards around those things. We need some more structure in the management of security credentials nationwide, and that's being worked on, but a lot has been accomplished in the first few years here. When we started deploying, security certificates really weren't available. The bottom line of some of these lessons is that this C-V2X hardware is ready for deployment. It's mature, it's available, and it meets these requirements, and it's ready for you and I to deploy. ITS America recently made a major step by producing a national V2X deployment plan, which gives you and I guidance. If you want to know where to start and what to do and how to do it, this document, and I've shown a link here, will give you some really good insight about starting to plan deployments. We expect a broader national deployment plan from the USDOT sometime early next year, an interoperable connectivity plan, and we've been working with them on that plan, as many of you have, and so we're excited about that. These deployments, we also found, can bring short-term results. We started with transit signal priority and been able to improve transit reliability and reduce schedule deviation. On our snow plows, it reduces plowing time and removes hazardous conditions on the roadways more quickly. We've been able to justify our early deployments by bringing these short-term benefits, and that's been important in our ability to expand our system. We've also learned that it takes time for these deployments to occur. As we look back and sort of evaluate this, for an agency to procure, test, deliver, install, and integrate this equipment is at least a 25-month process. And that's in addition to sort of the project location selection and funding cycle. Some agencies may be able to do it in a shorter period of time. Some will take longer. But the message here is that agencies need to start now. We can wait for additional developments to happen while you're in this process. It's time to really get moving with these deployments so we can get ready for the vehicles that will come. There are still some issues out there that we're working on. Like any technology matures, it evolves. That's always going to be the case. We're still working on some issues on how to synchronize the devices in the cabinet so they're all in the same clock, working on some SPAT broadcast consistency in the message broadcast, looking at verification of maps and understanding how they really are working, looking at the SCMS features, particularly misbehavior detection, which is something that hasn't been developed yet so that bad actors can be identified, refining the use of how to get a source for the RTCM message broadcasted efficiently and how the OBUs will use that data. And importantly, we're working closely with the automakers to make sure that they can trust that the data we broadcast is accurate, consistent, reliable, and secure. That's really important. As UDOT moves forward, we've got a couple more corridors that we're deploying this year for transit signal priority. One is north of Salt Lake City in the city of Ogden, where we're just finishing deployment of TSP there. And two more corridors we're just getting started on that'll be completed later this year in Salt Lake County. We also have an Attain grant that was just awarded a couple of months ago that we'll use to replace all of our old DSRC devices that were deployed in 2017, 18, and 19, and we've just barely started that deployment. We also have a second ATC MTD grant that came from fiscal year 2020 called Utah Broadly Connected. We're in the early deployment phases of adding another enclave site in Logan, Utah, a university town, where we'll add additional TSP and preemption corridors. We're working on rural safety applications and intersection safety applications with a focus on vulnerable road users. I mentioned a new Attain grant that we were just awarded. We'll use this to expand RSUs statewide into cities and towns all over the state as we prepare for production vehicles. We also, over the next couple of years, will be figuring out how to institutionalize our operations and maintenance of these systems. As we continue to deploy and grow the system, we need to bring this together inside and figure out how to maintain them like we do our other ITS systems. Really quickly, you notice there are two other technologies we're focused on in our webinar series. The first one is distributed acoustic sensing. We have a broad fiber optic network of owned and shared fiber statewide, which covers most of our major roads, all of our freeways, nearly border to border. And you can use this fiber to sense events along the road. The fiber senses ground vibrations and can measure speeds and travel times. It can sense impact events like crashes, rockfalls, and avalanches. And that's what we've been working on with these with these vendors and consultants to really understand how we can make double use of this fiber, use it to know what's going on in our corridors. We spent considerable time tuning the algorithms to be able to identify things like avalanches, and we had a very heavy avalanche season this year in our canyons because we had a lot of snow. And we learned that fiber placement is critical. In webinar number 5, we'll dive into all of those details about these systems. Finally, our road readiness survey allowed us to look at whether our roads are ready for automated vehicles. More than half of the new cars today have forward-facing cameras. Those forward-facing cameras support things like lane keep assist and adaptive cruise control. And the effectiveness of these systems depends on whether they can accurately see and interpret our lane markings. And so we wanted to know how good our lane markings are, what we needed to improve, and whether these technologies could learn from that. And so we surveyed 1,400 miles of roads, processed that data to determine whether our pavement markings are effective. We did daytime and nighttime surveys. We identified some problematic issues, some places where our striping either was worn out or was done in a way that wasn't conducive to these systems. But most of our markings were adequate. So we've learned a lot from those systems, and this will be talked about in webinar number 6. We had another poll question, but in the interest of time, I'm going to skip that and go right to Q&A and turn it back to Muriel to see if we have any questions to address.
And we do, Blaine. Thank you so much for that presentation. Every time that, I see it, I learn more from you as well. So let's get right into some of the questions. We've had quite a number of them from our over 200 attendees. Let's see, we've got a question from Alejandro Sanchez Badillo. He asks about the RTCM messages. Are those RTCM messages being generated at the RBS or relayed over the internet from a CRS station?
So we've experimented with a couple of ways to do that. Our state GIS center has those correction messages available, and we get them from there, and we broadcast that. We process that message and broadcast it over our RSUs. I'm certainly not the expert in these messages. We'll talk about those on one of the sub-school webinars, or if you reach out to us directly, I can put you in touch with the people who do this, and they can have a detailed and complicated chat with you about that topic.
Detailed and complicated. That sounds exciting.
Yeah, it does, doesn't it?
Well, Mike Ramirez asks, what kind of vehicles have OBUs installed? Are they government vehicles only, or are there also like commercial and consumer vehicles with OBUs for testing?
Thanks for that question. Yes, they're all government vehicles. We started with our snowplows and with the Utah Transit Authority buses. We then expanded to our own fleet vehicles, sedans and Ford F-150 pickups and other things that UDOT employees drive. We then expanded to the city of Orem, where the same kinds of fleet vehicles were equipped, plus their snowplows and some of their emergency response vehicles, ambulances and fire engines. So far, they've all been publicly owned fleet vehicles.
Rod McDaniels asks, can you provide some orientation on anonymity of collected data, like privacy implications, if any?
So the J2735 standards for these 7 messages that I indicated to you have built-in anonymity. So when the vehicle sends a basic safety message, that message has no indication of what the vehicle is. It gives a vehicle length, but it doesn't give make, model, color, VIN, owner, plate, any of that information. So the data comes in from those vehicles anonymously. Now, there is a slight variation here. When we send a signal request message to seek priority or preemption at an intersection, our state policy requires that we know who's asking for that priority. And so we have a little bit of information about that vehicle, knowing that it's a public fleet vehicle. But the rest of the messages are by design anonymous.
That's good to know. Well, unfortunately, we are not able to get to all questions today. We have run out of time, but it does signal to us that this is a topic of interest to a lot of you, and we encourage you to participate in our upcoming webinars. Let me briefly share my screen here and show the information about our upcoming webinars. It's out of the way. Okay. We will also, we have information about these posted on the Utah Transportation Technology website. And we'll be sending more information to all of you. The link will be the same to participate in the subsequent webinars, where we will do a deeper dive on some of the transportation technologies that we discussed this morning. And with that, we really appreciate you joining us today, and we'll be in touch. Thank you.